As we did in our previous video, we're going to begin this problem by pretending that that 3 isn't there. And so solving the equation just cosine of theta equals negative square root of 2 over 2, we would do this the same way we've done before. Looking in my trig chart, I see that the angle that gets me a ratio, a cosine ratio of square root of 2 over 2 is just pi over 4, which is really just a reference angle. This is no different than anything we've done all week long, or if you've watched our previous set of videos. So I want to figure out what two quadrants cosine is negative in, and it turns out that cosine is negative in quadrant 3, and so there's a reference angle of pi over 4. And cosine is also negative in quadrant 3, so there's a reference angle of pi over 4. And so now finding these two solutions, well, I shouldn't really say solutions, since we are solving a fake equation pretending that 3 is not there. I get these sort of two starting out points as 3 pi over 4 as a first potential, or not really potential solution, as a jumping off point. And then this gets us an answer, although a fake answer, of 5 pi over 4. So if you need help finding those values out, I'd go back and watch a previous video. Those are not actual answers, though, to the equation we're solving. Really what we know is that now we're going to go back and use that 3 theta. What I know is that 3 times theta is equal to that angle that we found. So 3 theta equals 3 pi over 4. And then also 3 theta equals 5 pi over 4. And so what I'll do is I'll solve each of these equations for theta, and those will be my first actual solutions to this problem. So I'll go ahead and divide by 3, or what I like to do is just multiply by a third. That's a little bit easier for me to do in my head. When I multiply that by a third, well, I guess I could cross those out. And so I get an answer of pi over 4. If you used a calculator, that would simplify out as well. So that is your first actual solution to this problem. Pi over 4 is an answer. Okay? I'll do the same thing down here. Solving for theta, I'll multiply by a third, or divide by 3, and that gets me an answer of 5 pi over 12. And again, circle that. Those are our first two actual answers to this question. However, I'm going to get many more solutions to this as well. And if you recall, or if you watched the last video, I'm going to get more solutions because I've changed the period of this function. That b value has affected the period, and it's making our graph repeat or cycle more often. And so to find the new period of this function, it's 2 pi, which is the normal period, divided by the b value, which is 3 in this case. Now that can't be simplified, but what I'm going to do with that, it's not a solution, but what I'm going to do with that is I'm going to keep adding 2 pi over 3 to my answers until I can't have any more answers. And I know I'll hit a limit when I get something that's bigger than 2 pi, because remember, we want to be only have answers between 0 and 2 pi. And so using a calculator, probably, if you don't want to add fractions by hand, 1/4 plus 2/3 gets me an answer of 11 pi over 12. And that answer is less than 2 pi. I could check that by dividing 11 by 12. I'd see that's less than 2. Or just think about what your numerator would be if you had a 12 in the denominator to get a 2 as an answer. Well, if I had a fraction of 24 pi over 12, that would, of course, just simplify down to 2 pi. So as long as your numerator is less than 24, you should be good to go. So let's try it again. I'm going to take that answer where I left off and add 2 pi over 3 to that. 11 twelfths plus 2/3, again, if I use a calculator, gets me 19 pi over 12. That's less than 2, so circle that. That's another solution. And we can keep trying this. However, if I try it a fourth time, 19 pi over 12 plus 2 pi over 3 would get me an answer, I believe, of 27 pi over 12, if I'm doing my math correctly, which is a numerator bigger than 24. If I divide 27 by 12, it's bigger than 2. So even though that's an answer, it's not an answer in our domain, so I stopped there, okay? So there's 3 answers we found up there. Let's do the same thing down here. So let's go ahead and add 2 pi over 3 as many times as we can until we get a number that's bigger than 2 pi. And so adding it once gets me 13 pi over 12. That answer is fine. Adding 2 pi over 3 again gets me 7 pi over 4 once I simplify. That's also less than 2. I can confirm that on a calculator. If I add 2 pi over 3 again, I'm going to have a number bigger than 2. So that's it. I have 6 answers. And to answer this question down here, although we answered in the last video as well, it seems to be, although we'll break the rule in our next video, it seems to be that if we double our b value, we get the number of solutions. So 2 times 3 gets us 6, and there's our 6 solution. So that's a good sort of estimate to see how many answers you might get. Although in our next video, we're going to see how it might break the rules, and we'll talk about why the next one does break those rules.